So I take off from the previous lecture where we discussed about the acceleration due to gravity, small g, and we'll come back to this topic. Like I said before, these were certain things just to provoke you to the two things which are probe and ponder. And I told you that we will have the occasion to talk about this set of equations. V is equal to u plus at, s is equal to ut plus half at square, and v square is equal to u square plus 2as as they appear over here. And that means the next topic that we must have, I must introduce things to you and discuss with you the intricacies of the topic. So let's start with motion. Motion. One of the premier things which we have been pondering over for millennia, and our studies and discussions and counter arguments to the arguments, etc., they have resulted in the understanding of the three very basic fundamental things. Like you have number one, time, the concept of time, the concept of distance or displacement, and their correlates, and the third thing is about mass. So I write T and this is the length and this is the mass. These are three things which are related, and then if you look into the units, etc., then currently we have this as seconds, S is defined. You can look into the definitions, and in the system that we subscribe all over the world, this is meters, and then the mass, which is taken as kilograms. So this gives us the system, the SI system, System International, the SI system, international system, or this is also called meter kilogram second system. But back in 1960s, when I was a student, then there was a CGS system. and centimeter, gram, second system, and before that the FPS system, where the units were the British units, which are still being used, less in Britain but more in the United States of America, where we have for distance feet, yards, and furlongs, miles, etc. And for kilogram we have pounds. Seconds, of course, has remained in the foot, pound, second system, pound, second system, which used to be there. So I started my studies with this system, and then later in a few years' time I learned about this system, and then this system, MCAS, was adopted, which was later called the. Now, I will not here indulge myself and talk about the definition of second, the definition of meter, the definition of kilograms, okay, kilograms, kg, etc. So these are some of the very fundamental quantities, along with some more, which I will not mention here now, like ampere, like candela, and like Kelvin as the temperature, etc. When the dimensions change, so do we have some more fundamental things. But these are the fundamental things in terms of which we define many other variables, many other systems. So first of all, I start with the point of reference. We have to choose the point of reference, which I can say that this is x is equal to 0, and then I move on to another point in space. And what is a point? Point is a dimensionless thing. It has neither got a length, nor a breadth, nor a height, nothing. So, but still, for the sake of representation, we have to show it this sizable amount, like a bullet. So, x is equal to 0, and in this direction, if I move to a distance, say, which I will call in mathematical connotation as x is equal to x. So this is value, and this is a feature. So x is equal to x. So therefore we can say that from here to here the distance is x. Another way of showing and another way of understanding. So this is distance. Distance. I will leave it for the time being how a distance becomes say displacement, but distance is equal to, in the system of units that we have, x meters, which I will show by the symbol small m. So this is distance is one thing. Now that means we are moving from one point to another point in space, and the space that has been defined right now is, and in the plane that we have the board, I'll just show that it will be possible for you to understand. Like in the geography, this direction is north, this is south, this is east, this is west. So I'll say that this is this direction right now, which is a horizontal one. This is indicating x, and in this direction, of course, if we go in the opposite direction, we show minus x. And just perpendicular to it at 90 degrees, there is, now I'm for the first time using the term axis, there is a y-axis and there is a minus y-axis. So I could move from this point 0, which I can indicate as this one, as the cross section at the cross of the two axes, and suppose I move in this direction. So I am using the term direction and I am moving here to a point like this. Now, this is the distance from here to here. Of course, you can see that if I want to go to this direction, if you want to define this direction, then I will have to define with this reference to the x-axis here, the east part, and then there is, of course, like I told you before in the case of the circle, that there is an angle, and this angle we normally call theta, measured in, though it is a dimensionless quantity, it can be measured in radians and also it can be measured in degrees following the historical perspective. So I am not going to waste your time more on that because I have to deliver more. Suppose this is the distance which has been moved, but from one point to another point you have moved, you know that we require something which is called the time t. So I'll say that in moving we have spent, we have used a time t. So here I'll say that this is like before, this is t is equal to 0, and then this is t is equal to t. So there is a change in the value of time, and I can write this as say the change in the value of time, always using this symbol delta. Delta t is equal to, in this case, t minus 0 is equal to t, of course, second. And this one as I can say that the change in the value of x, will be equal to the value x minus the value 0, and therefore this turns out to be x meters. So on the average, or just to understand this thing, we will say that there is something, we are going to define that something is as speed, which we use in our language of daily use. Speed. Speed is what? This is the value delta x upon delta t. We measure these quantities. These are measurable quantities, and I can write this as the value after some time and the value in the beginning. Also, I can write this as the time that we measure and in the end to the time in the beginning. So this speed is delta x upon delta t, and therefore it follows that it must have a unit of, because x2 minus x1 is, both of them are in meters, so this is meter minus meter, of course it is meter, okay, it's not 0. So meter divided by second, or meter per second, or meter second minus 1. So this is speed, and now I can say that the average speed, yani speed average, this is equal to total distance which has been traveled, total distance in meter, distance divided by total time. Let us take the example of a kid who is going to his or her school and then comes back in the evening from her school. Okay, so the total distance, and let her be walking the distance. So these days it could be in say hundreds of meters, but in my days I used to go on foot to my school up to the normally, and that used to be in kilometers, and I used to take almost 1 hour and 1.5 hour, etc., etc. So total distance, suppose the kid goes to the school 500 meters and walks back another 500 meters. So 1,000 meters, and takes, say, a time of 6, let me be, not 6, let it be 5 hours. 5 hours. And you know that each hour is 1 hour is equal to 60 minutes, and each minute is 1 minute is equal to 60 seconds. So using that, I can say that the child has taken 1,000 meters. 1,000 meters is the total walk, total distance that has been traveled with the child, and in 5 hours. So 5, I'll say into 60, this is seconds, so it is 1,000 meters divided by 6 are 36, 5 are 180, 1800. So it is 1,000 meters divided by 18,000 seconds. We can just see that it is equal to this is equal to 1/18 meter per second. Now this is, so I define speed as delta x upon delta t, and average speed average is equal to delta x upon delta t meters per second or kilometers per second, etc., etc., kilometers per hour, etc., etc. So there is a need to learn scaling. Scaling means how we convert, say, 6 hours into seconds, 6 kilograms into grams. That is called the scale. So this is, speed is defined as delta x upon delta t. Now, as I said, that we can also put another feature in this distance, and then I go from distance to what is called displacement. Displacement. Displacement, which has one feature is the distance, and the other feature is the direction in which the distance has been covered. So for example, and I will write this displacement also in the one dimension, x with a arrow or the head of this x, which is how we express. But again, the unit shall be the same. So the direction has to be specified. The direction is specified. There are two features now. One is for displacement, one is the feature of distance, and the other is, it's suppose like this. This is the initial position, this is the final position of the object, okay, and now this is not along the x-axis, not along the y-axis, but in any direction. So the direction has to be specified, and this is distance plus direction. Rather, I'll say that instead of calling this distance, if in case we are defining any vector quantity, this quantity is a vector quantity. So a vector quantity, suppose we say that there is a vector A. A vector A has two features. One is the magnitude of the vector. One is the magnitude of the vector, magnitude of this vector, which we show like this, and the other is the direction of the vector, which is specified by a direction vector A cap. This is, now this becomes equal to, for example, I can say that this is equal to A, which is the magnitude of the vector, and A cap. So naturally, if the left hand side, we make an equation, and in the left hand side I have a vector, then on the right hand side also there should be a vector. If this side is a scalar, this side also should be a scalar. Okay. So in that way I can write that my displacement like this is equal to x cap. There will be occasion to define this quantity, and then if this is divided by or the, instead I have delta x divided by delta t. Now this is, I am going to introduce to you another term. The definition is that this is equal to, by definition, what we say is the velocity. Now, for this small introduction, for what I said, that probe and ponder. So this of course will become meter per second as the unit of velocity. So like velocity, here the velocity is not a vector, but the velocity has been shown to be only the magnitude of the velocity either at any time t or initially and acceleration a. All these things have been taken as scalars to make you understand in the beginning that we have as to how the things go. So v is equal to u plus at, s is equal to s or x minus x naught, ut plus half ad square, v square is equal to u square plus 2as. These formulae should be derived by a young student or his or her mother alike, should at least be derived by the student maybe 2 times, by the mother maybe 3 times, because the mother has to teach and answer the queries, the beautiful queries, the inbuilt queries, the inbuilt question. And we have to provide the answer. And so in the next lecture we start from here and we talk more about these things and derive these formulae. Okay, so I hope that I have been able to deliver. I cannot teach you each and every word of the book, so I suggest to you that you visit one of the very nice books that I will recommend for all the students and their parents is the NCERT book of basic physics for classes 9, 10th, 11th, 12th. Search there, and here a student who has kept his books from the previous classes, which she can consult time and again to refresh oneself, is better off as compared to a student who has passed those books on or thrown them after they have passed the class. So please look into the things, and with the 2 words probe and ponder, and then when I come back we discuss more things about these equations and where they are applied. Okay, so long.